Hi guys, welcome to our fifth session of UVM. So guys, in today's session we will discuss about how to verify a GK flip-flop using UVM test bench structure, right? But we will not discuss about UVM test bench structure coding because it is a part of paid training program. But I will show you how to verify this and how to verify this GK flip-flop using UVM, right? And we will also check the results. So guys, before going to the topic, we are actually also providing some paid training program, right? So let's see what are the training program. Actually, for level 1, it is advanced digital design. This is the level 1 program offering by us, right? So this concept advanced digital design or switching theory or digital electronics plus one project. The next thing it consists, that is verilog HTL plus project. Next thing it's include system verilog plus project. And next one is UVM plus project. So this is the complete course, complete front-end verification course for the person who are right now who are fresher and looking for a job in VLSI domain, right? Apart of that, as a complementary, we will discuss about some important things which is very important in a point of interview or written test, like low power VLSI. Next one is power saving technique using gating. Different type of gating will be there, like clock gating kind of thing, right? Next one is very important topic is CMOS and their power dissipation. Next one is digital circuit designing using CMOS, and basics of analog electronics, right? So this is course for level 1. Next one is level 2. So the fee will be around 45,000 for this program, and for level 2 fee will be about 22,000, right? Level 2 program includes system verilog plus project. Next one is UVM plus project. Next program is that is level 3, and the fee will be 12k 12,000. So it includes only UVM plus project, right? So we are offering some training program, as I mentioned over here, and a part of that we are also providing trainings on protocol. like high speed protocol, like AMBA, like AXI and ATV. Next one is low speed protocols like SPL, right? So now comes to our main topic today about designing and verification of JK flip flop, right? So guys, as we know, JK have two pins, J and K as an input, and output is Q, right? So J is similarly to your set pin and K for reset pin, right? So let's write the code in Verilog. So first of all, we need to declare a module. Module name, let's say, is GKFF and module, right? So the pins are J, K, Q, reset is RST, and clock is CLK, right? So let's declare the which pin is input and which are output. So input is J and K is also input. Reset and clock, right? And your output is only Q. So let's declare one range to store the value as on temporary basis like Q underscore tab. Okay. Now write always at the rate positive clock. Now if reset is equal to 0, then begin, and if reset is 0, then we are saying that Q time should be equal to 0, right? Else means if the reset is not 0. So begin, and let's write some case. JK to tick the 00, on that Q underscore time should be equal to Q underscore time. Means if the value of J is 0 and the value of K is 0, then the value of Q time should be same. Okay. So let's say if the value is 0 1 1 0 and 1 1, because there are only two inputs J and K. So the maximum combination will be 2 raised to the power 2, that is 4, means 0 0 0 1 1 0 and 1 1. There are total 4 combination, right? So in this case J is 0, K is high, that means we are doing reset. So it should be 0, right? Here J is 1 and K is 0, that means we are doing set operation, right? So it should be 1, right? But here J is also 1 and K is also 1, that means we are doing set and reset on the same time. So the value of q will be complement of q. It will be toggles the value, right? After that, and case, and also let's connect this q temp register to the this output using assign statement that is continuous in nature. Assign q is equal to q underscore temp. Okay, so that's it. So guys, now here we can paste the code like this, and I already make UVM testbench, so we have to upload all these files over here, right? Now we have to run the UVM library, that is UVM 1.2, and the tool. Okay, let's use ment requester. Okay, so let's run the code and see whether it is working or not. So as you can see, there is some problem. Okay, it is saying cannot include file dut.sv. We already write the code in the design section. So let's go to the top file and just comment this line. Okay. So guys, you can see here we have include UVM package, import and include. After that, all the necessary UVM test bench structure file, that is interface file, transaction file, driver, monitor, scoreboard, agent, environment, sequence library, and our test library over here, and the test case name is jk underscore test. Okay, so let's run it again and see what happens. So guys, you can see we have total fired 27 test cases, and all test cases are passed. Test case passed is 27 and test case failed is 0. So we have to write all these kind of things. This logic will be part of our scoreboard. Okay, so let's see the results, how we can check. So let's come to our first test case. Okay, over here. So it is the reset condition. J and K is 0, and at the reset condition it will be Q is 0. So guys, here you can see the two things. One is pkt.q and next one is Q underscore exp, that is Q expected. So pkt.q means whatever the value we are fetching from our design, that is pkt.q, right? And q expected is actually there is our scoreboard is there. So scoreboard consists some golden model, means the design is written by the design engineer, right? So it is a black box for a verification engineer, but verification engineer also need to write a design in system verilog inside the golden model. Golden model will be a part of our scoreboard, and the whatever the value of j and k we are feeding to our design using interface, the same value of j and k, the same test vectors of j and k we have to feed to our golden model inside the scoreboard. And on the behalf of that golden model, it generates some expected value of q, means whatever means what value should come as the output, and we can compare that value to the value coming from our dut sides, means expected value and the value of q coming from the dut should be same. In such case, if the both value are same, the test case will be passed, else it will be failed. Okay, so again, the value of j and k is 0. As you can see also, j is equal to 0, k is equal to 0. So both will be 0, right? So this is the packet structure, the name, type, size, and value. Okay, and this is showing the timing for 47 nanosecond. Again, it is 0, so it will remain 0. Now, the value of j is 1 and k is 1. So you can see in the code, the value j is 1 and k is 1. So means at that point when the both value of j and k is high, so q should be the complementary of q. Whatever the value of q is previous will be complement. Means previous value was 0, so it should be now it should be 1. As you can see, packet dot q is 1. That means the value coming from this packet, that is this q, is high and expected value is also high. So in such case, the test case is called passed. Okay, as you can see, test case is passed. Now it is 0 0. So at 0 0, q time should be q time, means no change. So you can see previously the value of q was 1 expected as well as from our dut, and it is also remains same 1 high. Now 0 0, so it remains same. For 0 0 it remains same. For 1 0, so you can see here 1 0, 1 0 is the set condition, right? It is called set, it is called toggle, it is called reset, and this condition called no change. Okay, so the value of j is high and q is 0. So the value of j is high and q is 0, so it should be set. So the value will be 1. Right? Again, it is j is equal to 1 and k is 0. So set condition value should be 1. Test case is passed. Now j and k both are high. That means the toggle condition. So previous value was 1 expected value and the dut value, right? So it should be 0. So test is passed. Now again set condition, it should be high. Okay, test is passed. Good. Now 0 0, that means no change. So previous value remains same. That is 1 1 and it is 1 1. Okay. Now j is equal to high means and k is equal to 0, it is set. So you can see the value of q is high. You can also check over here, the value is high expected as well as from dut. Now 0 0, that means no change, it remains same as previous high. Now this is 1, so it will be high. Now this is the reset condition. J is equal to 0, k is equal to 1. You can see over here j is equal to 0 and k is equal to 1. That is reset condition. On that point, the value of q will be 0. So you can see the expected value as well as from dut value will be is same. So test is passed. Okay. Now again that is reset. So it remains same 0. Now 0 0, that means toggle. So previously it was 0, so it becomes high. Sorry, 0 0 is for no change, right? So previously it was 0 0, now it is 0 0, no change. Okay. Now again no change, that is 0 0. Again no change, so it remains same 0 0. Again it is set reset. Reset means again 0 0. Now this is set. So previous value was 0 0, now it becomes 1, as you can see. So guys, this is the way how we can verify a design whether it is working fine or not using UVM test bench structure, right? So if you want to learn all the UVM, all these files, how we can write all these things, so you can ping me on my WhatsApp number. I will share my WhatsApp number on the description box. Also, if you are not familiar with the basics of UVM test bench structure kind of thing, so I will share the link inside the description box. You can see that videos available on my channel, right? So guys, if you have any doubt or query, then you can also ping me on my WhatsApp number or you can make comment. Okay, thank you guys.